So while we are telling about the unit impulse signal. Okay. So impulse signal, sorry, step signal. So for step signal, what is told about step signal, that it will look like this. If it is the 0 point, 1, 2, 3, 4, 5, dot, 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 n, this is the n, and this is represented as what un. So it will have always the value same. Only for n greater than equals to 0. That means the right hand side or the positive side of the graph. So this is n equals to 0. This is also here. And let us name this as the amplitude is A. So I write here un equals to A for n is greater than equals to 0. And equals to 0 for n is lesser than 0. Okay. Now for unit step signal, as the name specified, unit, that means this A will be changed into 1. So un will be unit value, that is 1 for n is greater than equals to 0, equals to 0 for n is less than 0. So that time the graph will be same, the value will be changed, and the value will be, it will look like this. All at the unitary value. -1, -2 is 0. There we know that. And this is represented as U. So this is the unit. This is the unit step signal. So this is number 2, that is B. C, RAM signal. RAM means RAM. That means like this. This is a RAM. So the signal which will look like this is our RAM signal. So what is the definition of this signal? I am just telling you unit ramp. Okay, ramp signal and unit ramp signal will be difference. If it is unitary value, then it is a unit ramp, and if it is any arbitrary value, then it is ramp signal. Okay, so I am defining you all by unit. That's why it will be okay for you. तो रैम्प सिग्नल को रिप्रेजेंट करते हैं हम लोग आरएन से, आरएन से हम लोग रैम्प सिग्नल रिप्रेजेंट करते हैं. So Rn equals to n for n greater than equals to 0 and equals to 0 for n is something 0. That is RAM signal. So how will be the signal look like? What I told, Rn equals to n. So this is 1, this is 2, this is 3, this is 4, this is 5. And it will be n days also. This is n, this is Rn. So how I will represent this? If for Rn equals to n, it is telling. So at n, if I put the value of n equals to 0, then the value of Rn will be 1 here. So at 0, it will have the value of 0. At 1, what will be the value? Anybody?
Zero, sir.
No.
One, sir.
Yes, 1. At 1, it will be having the value of 1. At 2, it will have the value of 2. At 3, it will have the value of 3. So this is all RAM signal. So as the value of n will increase, the size of the RAM will also increase. So this is the RAM signal. So as the value of n will increase, the slope of the ramp will also increase. So this is our ramp signal. We will have an increased value of n of amplitude as the value of n will increase. So that is our ramp signal. Okay, at n equals to 0, lesser than 0, it will have no continuous signal. That means at n is lesser than 0, this is not having any kind of values. So that is the ramp signal. Next, exponential signal. Sorry. So exponential signal is represented as exp of n. Exponential signal is equal to a to the power n for n is greater than equals to 0 and equals to 0 for n is less than 0. Now, depending on the value of a, there are 3 types of exponential signal. If the value of a is such that a is lying between 0 but less than 1, then it is called decreasing exponential signal or exponentially decaying signal. So what is this? So like this, if a signal is there, if it is 0, if it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, this is n, then it is exp of n. So if the value of a lies in between 0 and 1, that means it is greater than 0 but less than 1, then the exponentially decreasing signal. So I write here exponentially decaying. And another is exponentially rise. So what is happen when a is greater than 1? At that time it will be having exponentially rising signal. And that will be like this. So like this it will happen. This side is n, this side is exp of n. This is 0, 1, 3, 4, 5. So this is exponentially rising signal. So these are the two exponential signals. So now it is a task for you. What will happen if a equals to 0? Anybody can tell me?
Sir, 0, sir.
Zero.
Yes, sir. Exponential value will be 0.
So that means it will be a straight line. Like this. Okay. So these are the exponential signal. Just in case I have told this is actually not considerable place. Just in case. So next is very important for us is a discrete time sinusoidal signal. Now what is sinusoidal signal? Sinusoidal signal are very commonly used signal. There are two types of sinusoidal signal. One is called cosine signal and another is called sine signal. So what is discrete time sinusoidal signal? So this is very important, very, very important. And properties of discrete time sinusoidal is a very, very important one. We have questions on this sinusoidal signals. So next portion is called E. Discrete time sinusoidal signals. So the discrete time sinusoidal signal are expressed as xl equals to a cos omega 0 n plus phi, sorry, plus theta for n in the range minus infinity to plus infinity. And another xl equals to a sine omega 0 n plus theta for n in the range minus infinity to plus infinity. Now, where omega 0 is called frequency in radian per sample. Theta equals to phase in radians. F0 is equal to omega 0 by 2 pi. That is equals to frequency in cycles per sample. Okay. So representation of the signal. If I see this signal, just a minute, I am going to see the signals. Just stop sharing in a minute. Just a minute. I am showing you discrete time sinusoidal signal. Because if I draw it, it's not a problem, but what will happen when I will draw it, it will have a problem. So let us see that. So you can see this is the discrete time sinusoidal signal, and this is a cosine signal. Now this is very much important. Discrete time sinusoidal signals. Properties of discrete time sinusoidal signals. Number one, the discrete time sinusoid is a periodic only if its frequency f is a rational number. That means xn is periodic with period n equal greater than 0, if on only if x of n plus n is equal to xn for all n. So much smallest value of n for which this equation is true is called the fundamental period. So let us do this as proof. So what I told, properties, number one property is what a discrete time signal sinusoid is periodic only if its frequency F0 is a rational number. What is rational number? What is rational number?
The P by Q form.
Yes. Ratio of two integers. Rational number means ratio of two integers. If the ratio of two integers, it is called rational number. If it is not an integer, then it is not called a rational number. Okay. Number two is discrete. I'm writing DT, okay. Please understand. Whenever I write DT, that means discrete time. Discrete time sinusoid whose frequencies are separated by integer multiple of 2 pi are identical. That means x of n equals to a cos in third bracket omega 0 plus 2 pi k into n plus theta for k equals to 0, 1, 2, dot, dot, are identical in the interval minus pi omega 0 to plus pi. That means if omega 0 lies between minus pi to plus pi, they are identical, and so they cannot be distinguished, so they are indistinguishable. Okay. So how to prove this? That a cos W0 plus 2 pi k n total n plus theta for k equals to 0, 1, 2, dot, dot, dot are identical in the interval minus pi to plus pi. Omega 0 lies between minus pi to plus pi, and so they are indistinguishable. So if I can prove that they are two identical, then it is indistinguishable. So let us see if I can prove this. So let us do the proof. Cos, what is that? Omega 0 plus 2 pi k n plus theta equals to what I can write? Cos omega 0 n plus 2 pi nk plus theta. If any trouble, please ask. If any confusion, please ask. Because when I am doing the proof, I cannot know where there is a trouble for you. W0n plus theta plus 2 pi. That is equals to cos of omega 0 n plus theta cos of 2 pi nk. That is equals to, sorry, minus sine omega 0 n plus theta sine 2 pi n. Cos theta minus sine theta. 2 cos theta is equal to, since n and k are integers, so cos of 2 pi nk equals to 1 and sine of 2 pi nk equals to 0. Why? Cos of 2 pi is equal to 1 and sine of 2 pi is equal to 0. That's why if I multiply it by nk integer, so that will give you the value of 1. And sine of 2 pi, that is 0, into nk is the integer, so it will give you 0. So we can write cos of omega 0 plus 2 pi k into n plus theta can be represented as cos of omega 0 n plus theta. For k equals to 0, 1, 2, 3. Okay, so this is the proof. So what do we conclude from this? The sequence of any two sinusoids with frequency in the range of omega 0, which includes from minus in pi to plus pi, are distinct. Okay. So conclusion, if I write the conclusion here, if I write the conclusion, if I write number 1, the sequence of N2 sinusoids with frequency in range minus pi lesser than omega 0 lesser than equals to, sorry, greater than equals to pi. Or we can write what? Or minus of half lesser than equals to f0 are distinct. Why this can be written? Because I divided it by 2 pi. So omega by 2 pi is equal to what? F. Number 2 is any discrete, any dt sinusoid with frequency omega 0 is greater than pi mod will be identical to another THE, another dt sinusoid with frequency omega 0 is lesser than 1. Okay. No problem?
No, sir.
Okay. So if there is any problem, you can share me because the time has ended. Less than a minute is there. I hope you have understand. And if you problem, you can talk now or you can tell me. So no problem. So within a
No, sir.
minute, the link will be disabled. So thank you for attending the class.